Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's video, we will talk about some challenging questions from kinematics. We call these questions challenging questions because these questions you cannot simply do by just memorizing physics concepts. In order to answer these questions, you should be able to apply physics concepts in real life situations. Here is our first question. So let's try to answer this question now. First of all, we need to read question carefully. We need to understand what is given in the question, what we need to find. So first of all, in this question, it is given to us that a stone released from rest. From rest simply means that its initial velocity is equal to 0. Now, the second thing is given to us. It covers a long distance in air. It means effect of air resistance is not negligible. So this is very important point when we read this type of question. We need to always look for air resistance. Is the air resistance is ignored or is the air resistance is present? In this case, air resistance is not ignored. It means we need to consider effects of air resistance. So let's try to sketch this one. The best way in physics is that always sketch. So let's say this is our stone and it starts from rest. Its initial velocity is equal to 0. And at the beginning, only one force is acting on the stone. Let's say that force. Now we simply understand that force has to be mg, gravity. Now, as the stone will gain speed, mg will not change. As the mg is not changing, but air resistance will increase from 0. So here is air resistance. So air resistance is increasing and it will oppose the motion of the stone. Stone is falling down. Air resistance will act up. Now let's say finally stone reaches a point where mg is equal to air resistance, means these two forces become equal. So these two forces become equal. So this is F air, means mg is balanced by air resistance. So at this point we can simply say F net has to be equal to 0, or simply we can say object has reached terminal velocity. Terminal velocity is the final maximum velocity. So the Vt is terminal velocity. Vt is called terminal velocity. We need to be very clear about that. So this is called terminal velocity. Terminal velocity. Vt is terminal velocity. Now, if we think about net force at the beginning, we can also say that F net is equal to mg. And at this point, we can also say that A is equal to G. And at this point, F net will be smaller than mg and A will be smaller than G. Now, we have this data, means we have this information. So now we can sketch velocity time graph. So the best way is to sketch velocity time graph. So we can sketch v on y-axis. So this is velocity, this is in meters per second, and on x-axis we have time, that is in seconds. Now let's try to sketch this now, how the velocity time graph will look like. Velocity time graph, if we sketch, it will look like this. So at the beginning, A is equal to G, and at the end, A will be equal to 0. So we have these two information now. A has to be equal to G, means it has to be maximum at the beginning. So this is not possible. A is not 0 at the beginning. And this is also not possible because acceleration is changing, is not constant. Now, look at B now. It is okay. It has certain value of acceleration A here and it is 0 here. But acceleration is not changing linearly. So this one is not possible. So our final answer is D. So this is A at this point is equal to G and at this point a is equal to 0. So this is how we can answer this question, and also this is kind of typical graph between velocity and time and acceleration and time for skydiver or for falling bodies. So it's also important to keep in mind this one for skydiver or for falling bodies in the air. In the air, so air resistance is not ignored. Okay, it's not ignored. So this is how we can answer this question. I hope this was quite clear to you. If you have any questions, you can just leave in the comments section. Okay, so our answer is D. Let's try to answer this question now. This is our second question. So first of all, again, we need to read this question carefully. When you read question carefully, try to visualize and sketch the problem and then start answering question. So the first thing in this question is given to us, a hot air balloon is moving vertically upwards with a constant speed of this. A sandbag is dropped. It takes 5 seconds. And we have to find the height of the balloon when the sandbag was released. So how we can answer this one? So the first step we need to sketch. Let's say balloon was at this point when the sandbag was released. Let's say this one is the ground. This is the ground. As it is released from here, so it will go up. As sandbag is a part of balloon, its initial velocity will be the same as balloon. So the initial velocity is the same, means the initial velocity of the balloon, u for balloon. This is very important. Often some students, they get confused with this part. U balloon has to be equal to u of sandbag. So it is sandbag because sandbag was a part of balloon. So they have the same velocity. Initial velocity, they have the same. And now I will only focus on sandbag. So the initial velocity of the sandbag that is given to us, that is 3 meters per second. And here we can also little draw here arrow. So this is the U. Now, as this is in free fall, the effects of air resistance are ignored. So we can simply say A has to be equal to 9.81 meters per second per second. Now, what else is given to us? Now, this is our sandbag. It will go like this and finally it will land on the ground. So the question is asking us, we need to find out this vertical displacement. Let me write down, this one is equal to capital H. This is what we need to find. We need to find. And the total time taken is given, capital T. This is the total time that is given. This is equal to 5.00 seconds. This is given to us. Now, how we can find out? So in this case, as acceleration is constant, this is a constant, so it means we can use kinematic equations. So we need to find h, and in this case h is equal to s, means this is the vertical displacement, and we can use this and we can answer this question. Now simply we can use s is equal to ut plus 1/2 at squared. Now, before we plug in values, we need to decide one direction as positive. So for the sake of this question, as the motion is upward, initial motion is upward, so always we take direction of initial motion as positive. As it is up, so we will take upward direction as positive. If upward is positive, it means initial velocity will be positive. And as acceleration is always down, so acceleration will be negative. Otherwise, we can also write these arrows. If you are not very confident about that, we can also draw these arrows. Now, time is scalar, so we don't need to worry about direction of time. Now we just need to plug in these values now. So I can write down, this is the h and this is equal to s. and the u in this case is positive, so this is 3, and the total time taken is 5. So plus, or I can simply write minus. So because a is equal to minus 9.81, so here we have 9.81 and 5. This is the time square, 5 square. So if we solve actually this one, we will get the value of h, that is equal to 107.5, yeah, point 0.5, zero point 0.5 meters. But this answer will be negative. This answer will be negative. Now, maybe some student they get confused. Why answer is negative? Why displacement is negative? So we need to understand displacement. Displacement. Displacement means direction. Uh, it depends on reference line. Reference line. So we need to be understand reference line. As we took up is positive, but the ball is landing below reference line. So this is our reference line. If we take up positive and it lands below reference line, means the displacement above this one. If I take S anywhere, S will be positive, and below anywhere, S will be negative. So we got answer minus. It means it lands below reference line. So this is what minus sign is telling us, and this is also according to our sketch and also according to our expectations. Okay, so our answer is B. This is our final answer. Let's try to answer our next question now. This question is very, very important to understand kinematics. So let's try to answer this question. I have seen many students, they just get confused with this question because the statement of question is long and they really don't understand what question is simply telling them. So now, first of all, let me help you to understand this question, what this question is telling us. So first of all, you need to understand we have a marble. So the marble is here at this point. We have a marble. And this marble is attached with this fixed spot, and this is at stop, is at rest. So this is velocity here. This is the velocity is at rest. But then we have two light gates. So what is the purpose of the light gate? So what we can get with these two light gates? So the light gate here we are using to record time. So we need to understand we are using light gates to record time. Record time. So this is one piece of information we need to understand. We are using light gate to record time. Now, how light gate will record time? So there's a beam of light, as the name is light gate. So this is one beam of light, and here is another beam of light. So when first beam of light is cut, when the ball will reach here, it will cut this beam of light. So the timer will start. Timer starts at this point. And when the second beam of light is cut, timer will stop. Timer stops. So this is one thing we need to understand. So this is how it will record time, and we can measure this displacement. S is the vertical displacement. So this is first thing we need to understand. Now the second thing what we need to understand is that at this point, let's say this point is point A. At this point, u will not be equal to 0. At point A, u will not be equal to 0. So let me write down here, u is not equal to 0. It has certain value of velocity at this point. And time at this point will be 0 because it will start recording time from this point. So these two things we have to be very clear about that. Okay, so the second situation is given to us. It's telling us when light gate 2 moves to light gate 1, which is fixed. So means now we move this light gate 2 to this point now. So let's say here we have light gates at this point now. Now we need to understand is that is this initial velocity will change or not, or the time will change or not. No, time will not change, because timer will start when the ball will reach point A, and again the distance is the same, so u at this point will be same but not 0. So this is what we need to understand now, and then we can answer. Now S is equal to ut plus 1 half a t square. This equation is given to us, and you can also see on vertical axis we have displacement, on x-axis we have time. Now, as you can see, the u is equal to 0. We can simply write down S will be equal to 0 plus 1 half a t square. So let me write down again here. S is equal to ut plus 1 half a t square. As the u is equal to 0, so what we will get, S is equal to 1 half a t square. At square. So now we need to understand, if this equation, if we sketch the graph will look like this. So it means this one is true. This is possible. Now the second one, for example, the same equation we have now, so we can write down like this. If we divide both sides by t, what we will get? We will get, here will be u, and here we will get 1 half a t. So this will be 1 half a t. So let me write down, the space is not enough, so let me write down little proper way so you can see. So we can say S over t will be equal to u plus 1 half a times t. Now if we compare this one with straight line equation, means y is equal to c. Let me write down in a different way so you can see the clear picture. C plus mx. So this is what we will draw on the y-axis, and this one will be over y-intercept, and t is here, and our slope will be equal to m. In this case is the slope. I'm writing here slope will be equal to 1 half of a. So it will be a straight line, because this is a straight line equation, and this value is the value of u we can find from here. And as it is in free fall, there is no a resistance. It means acceleration has to be constant. So this is, you can see we have acceleration on y-axis and we have time on x-axis, because this is in free fall. So this is in free fall. Free fall simply means that a has to be equal to g. So this is also correct, and this is also correct. As you can see, S over t, on x-axis we have time, so it has to be straight line. But this one is not correct, because this is telling you that initial velocity is 0, but initial velocity is not 0. Okay, this one is simply telling you that initial velocity is 0, but the initial velocity is not 0. Initial velocity at point A is not 0. So this one is not correct. And this is actually our final answer, because it's asking you which graph doesn't show. So this is our final answer. So this one is our answer. So I will just write down here, this is our answer.